am going to do number 9. I think I'm going to skip 10 for tonight. We can go back to it. Because like I said, there's other ones I want to do, and then I want to give you guys a group quiz.
Group quiz?
Group quiz, yes. Group quiz means activity that you guys get to talk to each other and use your notes and et cetera. It's kind of forces you guys to do something, but it doesn't quite put the pressure on you like regular quiz. All right. All right, so we have two different heights of, I don't know, I guess there could be two different buildings or something, for some, whatever reason, we have two different heights that this holiday decoration is hung from. The decoration has a mass of 5 kilograms, but that means it has a weight of 5 times 9.8. Remember, this is kilograms, but 9.8 is acceleration due to gravity. And the units of acceleration due to gravity when you're using 9.8 is meters per second squared. So the force that it's creating is its weight. What is it?
49 units.
49 units. Okay, thank you. All right, so that's the force, and that force is directly down, okay? It's the direction of our force. So it's asking us to find the tension in each wire. That means the force that is on the wire to hold it up, okay? So this 3 meters and this 5 meters are actually, for what they're asking us, it's unrelated information. Okay, the angles matter and the weight of the object matters, but the 3 meters and the 5 meters are extraneous information for what they're asking us. So the tension in the length, I'm going to call the tension in this wire T3. Okay, so the tension in that wire, I'm going to call it T3. And I'm going to call the tension in this wire T5. So T3 times cosine of 52 degrees. Okay, remember cosine of 52 is adjacent over hypotenuse. The hypotenuse is the tension in this wire. So T3 times cosine of 52 is a tension in the horizontal direction. On this side, it's getting pulled by T5 cosine of 40 degrees, but the way I have the picture drawn, this will be a negative. So the way I have the picture drawn, okay, that like this rope is attached up here, you can kind of think of it's pulling the thing up in this direction. So this horizontal force is pointing that way, whereas this horizontal force is pointing this way. Okay, so the two horizontal forces added together is 0 because we're assuming that, I don't know if it exactly says this, but it's just holding the thing up, so it's, if we were told that it's swaying over to one side or the other, then though that sum would not be 0. But because they didn't tell us that the star is swaying to the left or right, we have to assume that the star is stationary and the two horizontal forces are kind of reacting against each other, creating a sum of 0. And then T3 times sine of 52 is helping to pull it up, okay? And then T5 times sine of 40 is also helping to pull it up. And that is going, the two of them added together has to equal the weight of the thing. If it didn't equal the weight of the star, it would be moving it upward, or the star would be falling. Okay, so the two, the weight of it is actually a force down, so like this is really a negative 49, but the ropes are pulling it up, so the sum of these together should equal positive 49. Okay, if they added up to something more than 49, the star would be moving up. If they added to something less than 49, the star would be falling. So we have a system of equations here to solve, and, you know, honestly, you could solve your system of equations in a lot of different ways. You could do Gaussian-Jordan elimination, we could do substitution. I think with the coefficients being kind of messy, I think I might do substitution, especially because these two add to 0 means that T5 cosine of 40 equals T3 cosine of 52. Okay, if I add this to both sides, then I would get. And then what you can do down here is you can use this, and you can either decide you're going to solve for T5, or you can solve for T3, it doesn't matter. So I've solved for T5, so I'm going to leave this as it is, but my T5 is going to become T3 times cosine of 52 over cosine of 40 times sine of 40. And then T3 can be factored out of both of those. Okay, so at this stage, why don't we try to get a decimal for that whole big thing, and here's where it's nice to have a graphing calculator with a big screen. Liam, can you not see, or is your back bothering you?
No, I'm so exhausted from doing the homework today.
Would you like to stand?